Hello, everybody. I am Pierce from the VS Code team, and we're here to talk about what we learned shifting VS Code from monthly to weekly releases. So I hope everybody's having an amazing build so far. There's been a lot of great announcements, and I think something unique that we want to show you in this talk is like everybody in their session is probably telling you, here's the thing we announced, some AI product you need to go try immediately, and that's like most of the sessions, right? For this session, we want to talk a little bit about like how our team had to evolve over the last year and a half as we actually adopted AI. Because there's a lot of changes to our planning processes, to our inner loop, to our engineering system that were necessary with this change. So like I said, I'm Pierce. I lead the PM team on VS Code. Josh, you want to introduce yourself?
Yes, I have been on the team on the VS Code team for a few years now, and I have seen our old process and our new process, and excited to show you guys all the cool work that we've done.
Great. So like I said, like I think probably everyone's boss is like, you should use more AI, and you're like, great, we're doing that. And then I think we started realizing like almost like starting to use AI, use agents, right? Starting in the editor, going from ghost text to Copilot edits to full-on agent mode inside of VS Code. That was kind of like the easy part, quote unquote. But then, like, as you actually are successful with agents, like I always ask, like, OK, you adopted agents. Like, now what? What actually is the implications of being successful with AI? And in VS Code, we really had to evolve the product significantly. We knew that. Like, VS Code has always evolved to meet the needs of what developers require, right? It started as a very simple editor. We added extensions. We added remote development. The latest evolution of this is AI. And that evolution was what, like 7, 8 years to get to that point. And then we had AI, and we rapidly had to evolve the product over the last couple of years to be what it needed to be. And agents were really one of the keys for that. But I think like when I first started on this team in 2024, I think the model capabilities weren't quite what they are today, right? So this is an interesting graph that's basically a code survival metric. So our team, one of the things we track is essentially like, for a given model, right, what percentage of the code produced by that state-of-the-art coding model is actually committed? Not that that's the most perfect metric, but it is a reasonable signal that like the developer has some level of confidence that this code should make it into the code base, right? And so maybe like a year-ish ago, state-of-the-art was GPT-4.1. And so we were seeing roughly 55% of code generated from GPT-4.1 making its way back into code bases, which is still really, really good. Like that was a massive improvement over what we had previously. But this chart is even a little behind. You can see Opus 4.6, we're at 86% of code generated by the agent making its way into a commit. And so when these models started getting better, you obviously can lean on them to do significantly more. That's the progress we saw in 1 year. Like it makes me wonder where we're going to be a year from now, right? And so, of course, like not that commits are the best metric, but it is a good proxy. You can see kind of how our commits drastically started ramping up, particularly like later in the year. Like, OK, we had December, we had some vacations and things like that. But as we entered 2026, you see the ramp just continuing to go up on commits on the team. OK, so we're doing more things, right? We do feel like it wasn't performative, like we're just committing more, great, we're using more AI. Like, I really do feel like VS Code got so much better over the last 6 months with all of that work that we were able to do thanks to agents. But the thing that maybe you won't hear in many of these talks is using AI successfully does create more challenges for you, right? So this is a metric just from January of this year. So you can see VS Code has way more issues than it did, roughly 3x more issues, right? And way more open pull requests since January. And this chart is continuing to grow, right? And so, yes, we're shipping more, but we're also getting more issues we have to deal with. We have more pull requests we have to go through. And so there was this moment we got to in January as we're starting to like deliver the product functionality much quicker, where we realized like, this monthly planning thing was always like a big part of VS Code culture. We were so proud we ship every month. And we had this realization like, that's actually now not good enough anymore. So then we had to move to weekly releases. We did that back in February. And there was a couple reasons. Like one was just the AI space was turning over so quickly, right? So we would have features that we would ship to VS Code Insiders, which is our daily build of VS Code at the beginning of the month. And then a competitor would ship it 2 weeks later. But we only ship VS Code to stable once a month. And so we were hearing like, oh, well, VS Code doesn't have this thing. So there was certainly competitive pressure to do more frequent releases. The model gains, really, we were doing a lot of special things for prompting and things like that we needed to get out there. So I'll talk a little bit about that later. And then, of course, like I used to work in Azure, and we had deploy freezes, right, all over the holidays. And so all the engineers are still working. Then you get back from holidays. It's January like 2nd or 3rd. You're back from New Year's. And everyone has all their awesome features that they've been working on for the past month and a half since before Thanksgiving and Black Friday and all the deploy freezes. And you want to know what happens that week? You don't want to be on call. Incidents, right? And so like when you have these large batches you're landing, that's an incredible amount of risk. And so because the team was doing more every single month, we also felt like we needed to like get these smaller batches out there so we could validate and make sure that nothing terrible was happening, where we weren't dumping a ton of things all at once. And so the rest of this talk is really like, sure, like you can adopt AI, you'll move faster, you'll deliver greater value to your customers more rapidly, but you also have to think about how you work. You can't just tell your teams, like, use more AI. You have to think about all your engineering systems and processes and how those things need to evolve with AI. And so we're going to hit on a couple different parts of that in our talk today, starting with kind of the developer inner loop inside of VS Code. Josh is going to show us that. We'll talk about some of the specific bespoke tooling that we built inside of VS Code for our AI native engineering system. And then finally, like a little bit more on like how we actually decide what work goes into VS Code in terms of planning and collaboration and our model there and how that's had to evolve. So with that, I'm going to pass over to Josh to show, switch over to 3, the inner loop for VS Code engineers.
Yeah, thank you.
Yep.
Yeah, so as I said, I'm an engineer on the VS Code team. I've seen the process before AI was a thing. And I've seen how our team has evolved over the past few years to really take advantage of all of the benefits. So I want to show a few different tools. There's a lot of tools I think that we've built, some that our entire team uses, some that only a few people use, kind of bespoke to their workflows. I want to show a few that I find really valuable for the work that I've been doing. I work a lot on the agents, I guess a lot on the agents integrations in VS Code. I work a lot on the customizations pieces of that, and a lot of UI, right? So one tool that I really love, and this is a PR from April that I wrote, and this was a change where we had just rolled out this new feature called Component Browser, which allows us to slice up components in VS Code in a way that the agent can work really well on them. And I really like this example because this was a change that would have taken time to build, to test, to run inside of our local environment. And all of this was done with a single prompt, and I was able to do all the validation that I needed right in the PR, really. And the change was simple. I just wanted to add a back button. You can see there's no back button. There's a back button now. And the way that this has been written is that this is both a change that's useful, or this tool is both really useful for a new feature and also for actually catching problems and regressions that are introduced as a side effect to a different change.
So this is basically running VS Code with your change and without your change and taking screenshots and then putting those in the PR.
So it's even more kind of simple than that. We have rewritten a lot of how our components are built in VS Code so that they can run outside of, so that we can actually inspect and inject data inside to the components outside of the product. So we don't need to run a full build of the product.
Nice.
And have that overhead, right, for every single PR. With the hundreds of PRs that we see a day, that's a lot of overhead, a lot of compute, a lot of time. So this is how we've kind of extracted that out to make it a lot easier. And it is a simple change here, but it saves a ton of time. It really boosts your confidence in the changes that you are making. And yeah, we have different, there's a whole lot of ways to slice this. And you can see all of the fixtures that I've created here and all of the ways that it validated that this change was correct.
And I like that it's just in a PR, so like if you're on the go, right, like you're not at your machine, you can like quickly open like the GitHub mobile app, you're scrolling through and you're validating the behavior there as well. You don't just have to be on your machine.
Totally. And I'm showing a change that I made, but from the community, these also run, right? So if there's a community PR that changes, say they wanted to add a back button or they fixed a bug that they they were inspired to fix the bug, but didn't know how to run OSS locally on their machine and actually test it end to end. They're able to use AI, and we're able to use AI as code reviewers to understand what those changes will have an effect on downstream. So this is just one thing that saves us all of this time for all these community PRs that are coming in. And yeah, we have it running in VS Code as well here, so you can see all the components that we have extracted out. We have buttons, we have toggles, anything in VS Code where we don't want the UI to change or regress without us knowing about it, we've extracted that out. And it's a simple change, but I think the mindset of how we use it really accelerates our development.
Totally.
Yeah.
Yeah, and I mean, we have VS Code on every operating system, web.
Absolutely,
it runs
right.
everywhere, and so there's a large test matrix that's necessary for each of these components.
Exactly. And yeah, we have, I think I'll just open this back up, and I'll just show you in chat how I just asked chat earlier to swap the button from blue to green. And you can see how this works, is that what it did is it took a screenshot beforehand. It was able to find the fixture because I gave it the name of the fixture that I wanted it to update. I said, keep iterating until it looks correct, and then go take a screenshot to show me that it's correct, and it turned green. And this is all in chat in line here. It was able to reload the component browser here, so it's interactive. You can see you can collapse these or highlight, and all of these UI interactions work the same as they would in the product. So one thing that I really find valuable that I don't think I expected to find so valuable, which is why I wanted to highlight it.
And it's running, like you said, like this is all running in your agent loop. So if for some reason the change doesn't produce what you want because it's looping over the screenshots and the output from the component explorer, like it can actually go fix that as well, which is nice.
Totally.
You get like the built-in verification behavior
Absolutely.
in the agent.
And that's when you are using agents to make a change in UI. It's just kind of guessing, right? There's this kind of feedback loop that is missing, and that's what this tool really solves.
Cool.
Cool. So that's, yeah, I love this tool. I have this running all day long. Here, the other ways that we've been collaborating a lot these days is just using the agent to build prototypes, right? So you saw what I was building before, which is the Agent Customizations UI, where we are extending that to kind of be a hub for other kinds of agent configurations across all Copilot surfaces right now. And me and Harold, someone on our team, have been kind of collaborating back and forth on this prototype that's up on his GitHub, and just using agents just to prototype as well. This kind of prototype is written in a way that it can easily be translated back into VS Code. So it's not just kind of wasted work. This is work that's helpful for us to communicate to each other, to other stakeholders on the team. Here's what our vision is for the product. And then this really translates nicely right back into VS Code. So it saves us a lot of work. It saves us a lot of back and forth on writing a spec, say, or on meetings. I think with our shift to weekly releases, we have to talk more. We have to communicate more, I guess, kind of, we have to talk more, like, we have to talk every single day to make sure that we're aligned.
Yeah, totally.
And this makes it a lot easier to do that.
Yeah, I think like the prototyping thing is very interesting because like as a PM, like I would always go write these specs, right? We never really did that on the VS Code team, but like a lot of teams do work that way, right? You go write some doc and no one wants to read this doc, right? The thing I always found unsatisfactory about that is it's all hypothetical, right? Like you don't actually know until you get your hands on an experience and you spend time with it. Oh, I like this, I don't like that. There's this edge case we didn't think about. And like, of course, pre-AI, you could prototype, but in many cases, it was very expensive. And so like, I think that's been a big shift for us on our team is like, very often we're doing things like using this prototyping tool to like explore new ideas, sometimes even doing the prototype itself inside of VS Code. And then, you know, the PM team will even sometimes send you PRs. And the point is not necessarily that you merge our PR, but that almost becomes actually the spec, right?
Yeah, and our team uses insiders every day, of course, and we ship insiders at least twice a day. Well, we do often more. And with a monthly release, that gave us enough time to feel out certain changes in the product. Now, with a weekly release cycle, we need a faster iteration loop, and that's what this kind of accomplishes. There's a few other kind of inner loop things that I've really kind of picked out in the sea of changes that we have. We have skills, of course, like everyone else does. These are all inside of the VS Code repo, so open source. Anything that you find interesting here, you can use yourself. One that I find interesting, or that I found really useful, is the chat performance skill that we've built. So we built a lot of tooling around being able to mock out complex scenarios in our chat renderer. We've encoded all this into skills that we use throughout the development process. And this, it explains here how it works. We have some tooling, but really the key to it is that we can use the skill to allow the agent to understand if our change is going to regress any kind of performance benchmarks that we've already captured here. And the outputs are really nice. The way that we can have the agent query, I just have this other chat prepped. All I did was run the skill /chat-perf in the VS Code repo. I, of course, didn't make any changes in this branch, so it won't find anything kind of funny. But what it does and what we use it for is if we're making a complex change to the renderer or to a portion of the code base that we think could be risky, or if the agent thinks that it could be risky, it knows to use this skill to identify if we should make any more considerations, essentially. And this is really nice, again, for the weekly releases, right? This is something that we don't have time as a development team to sit with it for an entire month like we used to in Insiders. So allowing the agent, or I guess teaching the agent the angles and the aspects that we care about is really important. And it's really helpful, right? This explains, we've got a set of benchmarks of like the timings that we expect, and it's very easy for a human to read. It's really easy to kind of query the results with a lot of SQL. We have a few in our skill that we encode that we found very useful. And it's really easy for a human to read and understand this, and for the agent to iterate on a fix, or at least say, hey, this part is a little funny looking.
Yeah, I like stuff like this because I think people are like, oh, I used AI to add more features to the product.
Right.
But I think like for us in VS Code, performance has always been like so central to like what we're trying to do there.
Yeah.
And like obviously we want to move faster with AI, but you also want to make sure that in doing so you don't degrade the quality and performance of the product. And so I love like these examples on how we're able to like still make sure that we have like a super high performance product that we're shipping, but we're still able to do so while moving fast.
Yeah. Yeah, and there's one, I think I have it here. There's one recently that was really cool that this had snuck into our product. We then started introducing this tool. We ran these benchmarks. We saw that there was a problem with, I think this was tool parsing. This was a tool parsing bug that was found and saved a couple thousand milliseconds off of chat on every single tool call that came in, which is huge, right? And this was entirely AI generated. Both what we found as the problem and the fix was at least kind of partially written by AI, and then also, of course, reviewed here by Paul. But it's just really fascinating to see what the agent could find, and this was across a few different processes within VS Code. This is not kind of a simple, straightforward, bug. Cool. And that, I think, are the two main agentic inner loop changes that I find interesting. But there are so many. There's like a dozen or so skills that we've added in the past month that our team's experimenting with. And yeah, there's a lot more that I don't have time to show you as well.
And the cool thing about these skills, right? Like, it's certainly true, like on every team, there is someone who's like, I know all about performance, right? And that is the trusted expert on the team. And I think pre-AI, the problem is that person was a bottleneck, right? For every single performance-related thing. And now, if you can take like that knowledge of what our expectation is, and maybe encapsulate as much as you can from that person's brain. It's impossible to fully do so, but like if you can take the key things and create skills or tools like that, then now like your whole team has access to this performance person that they can be running continuously, right?
Right, and I mean these skills were actually written by those experts, right? So it's encoded exactly what they think is important and allows us to all have agency and be able to take ownership of these bugs instead of just handing them off to someone else.
Totally. Okay, was that your last demo for this section?
Yep.
All right. Switching over like a pro. OK, so like another thing I wanted to talk about is like I think that when people are like, oh, there's new models in GitHub Copilot, I think they just assume like, oh, there's an API and you just wire it up and then the right things happen, right? But the reality is actually that there is an immense amount of effort, maybe like, I don't know, at least 15 to 20 people who are involved in these sorts of launches from different disciplines, whether it's engineering, product, marketing, obviously, data science, right, to get these models into your hands. And so we spend a significant portion of our time doing this, especially now that there's seemingly a new model being released from one of the providers that is supported in Copilot every week, right? So typically, the way this works is before launch, we have the providers, come to us. They, under NDA, they say there's a new model coming. They give us a ton of information about the model. We onboard it to this thing called Copilot API, which is like our essentially API gateway for all of our models in the product. And then we basically, over basically several weeks, we continuously loop over like how can we get the harness to do really well for this model. I think there's like an assumption that like you don't have to do anything in the prompting. But actually, if you go, VS Code's open source. If you go into VS Code and you type like OpenAI prompt, you can see actually the dynamic construction of all the prompts we do in the product. And every single word in that has a purpose. And so we spend a lot of time in offline evaluation, improving that, working with the model providers, going back and forth. How can we make this better to get resolution rates up and also token efficiency improved? And so we also have like internal dog food groups. So we're getting the qualitative feedback as well. And so there's like a whole bunch of things that happen. And then we finally launch the model. So that's kind of like what happens before we launch. But then after launch, we've also done a lot of investment in kind of our experimentation infrastructure inside of VS Code. So we have, if you have telemetry enabled in VS Code, we do run A/B experiments. At any given point in time, we might be running many of these experiments. We specifically run prompt improvement experiments. And so, of course, like I love offline evaluations, but they do have flaws, right? There's a lot of things you can't fully encapsulate in an offline evaluation. And so online experiments help us to have real data and actually make decisions about our prompts. And so very often, if you're snooping on the VS Code repo and you go to pull requests, after a model launch, you'll sometimes see us have 2, 3, 4 versions of these prompts that are being A/B tested in the wild. And we can measure a lot of the metrics we were talking about earlier. We can say, like, OK, how does this impact token efficiency? How does this impact retained code, the thing we had earlier? And so like usually like 2 weeks after a model launch is when we have done all the offline work, we've done the online work, we have the experiment results, and we've made decisions about like what we're actually going to ship. And so that's usually actually, ironically, the best experience we'll get with that model is usually about 2 weeks post-launch because we've had time to do both the offline and online evaluation experiments. So I mentioned evals. Like personally, we found like the evaluation, both the infrastructure and also the benchmarks insufficient. That are available in the public. And so obviously, like with all the model ships and everything, we wanted to make like objective decisions about what we're doing in the product. And so we built this thing called VSC-Bench. And that's essentially like our purpose-built offline evaluation stack for VS Code. And so that's the thing I was referencing earlier, where like we have our own cases. We have our own kind of infrastructure for running these evaluations. And we are running many, many, many of these every single day with different variations to understand the impact of different changes on metrics like tokens and resolution rate. So here's like a sample plot for total tokens over resolution rate. And you can see how that kind of changes. Like, yes, of course, GPT-5.5, you do have a better resolution rate. But sometimes at the cost of more tokens. So you can see like the different reasoning efforts are also overlaid here. So it's an interesting product decision we have to make is not just like, did we optimize the prompts, but like what reasoning effort do we ship with? And so like, of course, you could say, OK, extra high for everything. It's going to always give you the best results. But I think the interesting thing here is actually that's untrue, at least in our offline evaluation stack for GPT-5.5. And then there's also trade-offs, of course, with costs and things like that. So would you be willing to trade like 1% boost in resolution rate for a 20% increase in token cost? Like most people would not, right? And so those are the sorts of decisions you have to rationalize pre-launch. So that's VSC-Bench. That's our inner loop and kind of the things we do day to day. But next, I want Josh to kind of walk through the engineering system itself. And we always, I feel like, had a more advanced, like bespoke engineering system that we had built for VS Code. But we really had to evolve this thing in particular over the last couple months. So I'll pass to you to kind of go through that.
Thanks, Pierce. Yeah, so I think we have had a lot of very specific VS Code tooling since I joined the team, right?
Totally.
A lot of issue automations. We had a model trained for a long, long time that would try and infer who is the owner of an issue and other kinds of really simple tasks. But that has been so accelerated with the advent of AI and through agentic workflows, which is what a lot of this that I'm going to show you is built on. But first, this really overwhelming graphic here kind of gives you a good idea of how the system is interconnected with each other. We have kind of three inputs, right? We have events from GitHub, so these are issues and PRs, and all those signals, and those are kind of I guess, like the signals that we always used in the past. This is kind of the entry point to any change in VS Code is an issue to start. But nowadays, we have a lot of scheduled jobs that just, you can see, do all sorts of stuff that go through all of the data that we have and tries to find and understand errors and even fixes them. So that's one that I'll go through, the errors agent, which is really interesting. A lot of self-healing. This is work that we've done to heal our other workflows so that the engineering system as a whole stays healthy, right? Because that's something that I think you can build a lot with AI, but you need to make sure that as soon as you move on to the next thing, it continues to work and operate the way that you expect it to. And we found that at our scale, with the amount of issues that come in, with the amount of changes that we make, that's actually a bit more complicated than actually building these tools, is making sure that it's resilient and able to handle the load that we hand it. So a lot of thought has gone in there. And then, of course, we can also run these ourselves. We have a Chrome extension up here, which I'll highlight a bit of some of these like dashboards that are built into the Chrome and Edge extension. But this allows some kind of manual work to be done on an issue to automate some of the manual processes. You know, as I think any engineer on the VS Code team can tell you, a lot of our time in the past, and even now, is spent on just understanding and triaging issues and sending them to the right place. And the whole goal of our new engineering system is to save our engineers time so we can focus on actually writing code and actually building the product. So super high-level overview of our engineering system these days. I think we made updates to this yesterday, right? So this is continually changing its shape as we learn more. So I'll go into a bit of some of the triaging of the influx of the influx of GitHub issues that we get, because that is definitely our biggest signal when something goes wrong or when the community wants something changed.
Well, and I think obviously we're using more AI, which generates more issues for us, but also our community is also using more AI, which generates more things, more stuff for us to deal with, right? And so it's not even just our own volume of issues we're generating. We're one of the world's largest open source projects, and we're also getting a massive influx of community contributions now as
Absolutely.
well.
Yeah, and then understanding if an issue that comes in is something that is actionable by us or something that's actionable by maybe it's a service outage or something like that. There's a whole new kind of realm of issues that us as a client application did not have 4 or 5 years ago.
Yeah, I mean, we talked about the Copilot API thing. Obviously, we have a massive dependency to make sure that thing stays up for us. And like you said, we were just a client app. There was no connectivity risk really at all. Maybe the updater service was the only one we had, right? And now, to use the product, if you're using any of the AI features, of course, we use local models for some things, but the overwhelming majority of those things are going to some sort of online service.
Totally. Yeah. So we've built a lot of tooling around this to do auto triaging for us. We have a lot of data that we're collecting and trying to understand, if this is successful, when we have an issue that's auto triaged, is it successful or has it been modified by a human afterwards? A lot of really interesting data that we're collecting here, so we're learning more. You can see just how it works, which is really cool in here. So this went through, I guess, maybe 2 hours ago. It ran through an issue that it saw. Kind of peeked through. Let's see if there's some interesting ones here. Yeah, but you can see like we are going through all our issues and trying to find the owners for them. This is, I think this one shows you, yeah, so we had a problem come in, or we had an issue come in 4 hours ago. It found the assignees that were responsible for it, the areas that make sense. It identified that it was a feature request. And then we have some tooling to, if it's a bug or some kind of like regression, to actually fix that for us.
So how does it actually decide like these people are the owners for this particular issue?
Right. So we have a few sources of data for that. So of course the code base, right? If that's like the source of truth, right? If anyone's been committing in that area of the code base, that's a good signal. Obviously, we have a few other data sources where we manually say, I am the owner of X experience.
Right.
So I want all issues to come to me so that I can fix them or triage them appropriately. So we have many kind of sources of that. And you can see here it gave 3 owners, which is probably not the ideal way that we would divvy it up. So it would probably.
But I like that we can actually go in and see what happens, because like we also have to go and debug our actual engineering system for like, okay, you're saying you shouldn't have gotten 3 owners here. That's probably not ideal. Okay, now we can actually see the full log for that agent, what happened, go diagnose that, and figure out how we can get it down so there's not the multi-owner problem.
Yeah, and it also is really good at finding a duplicate issue and identifying that. And we can see that both on the automation side and then also as a human that goes into an issue. So this is injected by our Chrome extension that we use internally on our team. So this is not a feature of GitHub, but kind of one that we wish was a feature of GitHub, so we made it ourselves. So this allows us to dedupe different issues. We use AI. It runs every, I think, hour with the latest set of GitHub issues and tries to match duplicates. If it had been certain, it would have just automatically closed that as a duplicate. So that, again, our team is focused on not having to triage 20, 30, 40 issues that are the same root cause. We can focus on what's important. And this has saved a ton of time to our team.
Well, yeah, and it's very, it sounds easy, like just mark things as duplicates, but like there's so many issues that you can't just like from lexical search immediately find like the exact same issue. And so that's the cool thing is like this workflow is actually looking into all the issues, all of the text in it. It's not just the keyword matching, but also the semantic understanding of the issues, right, and how they all fit together.
Absolutely. And I mean, here, like this was like one that I randomly pulled. This is a great issue, right? It's super detailed. It kind of suggests what this author thinks we should do. But there's a lot that we don't get that have this much detail. So to actually do the deduplication is a lot more complicated.
Yeah, you mentioned that this like wasn't natively a feature in GitHub, and I actually think like one cool thing that I'm kind of hoping is like as a result of our work of like being one of the world's largest open source projects and having this massive influx and having to reinvent our engineering system, I think the hope is actually that we're going to try we try a lot of things that don't work as well.
Absolutely.
And the things that do work, like I would love to see make its way back into GitHub as a platform construct, right? Like there's no reason that eventually this duplicate detection shouldn't just be something you have in GitHub.
Right, and this whole work is built on a lot of the work that is offered by GitHub, a lot of like the agentic workflow tooling that comes out of GitHub, so that we can run these issues against an AI without fear that there will be some kind of prompt injection from the issue or any other kinds of concerns. There's a lot of consideration that goes into actually running AI on untrusted issues, right, from the community. So there's a lot that we've built on and a lot, I think, that we could share back.
Cool.
We also, like I said, we care a lot about the health of our pipeline so that we understand that all of our automations are actually working the way that we expect. So these are all of our, I just chose ones that are cron jobs here. The ones that I'm going to show next are these 3 error pipelines here. So I showed you how we do the auto triaging. We have a lot of information that we can infer from an individual GitHub issue. And then there's a lot that are actually actionable that we don't really need a human to go spend an afternoon working on if there's a clear way to reproduce the bug, clear goal. So we have this running every so often, a lot of times a day, that goes through all of our telemetry. And I'll show a little sneak peek of our errors page here. So this goes through any unhandled error, and there's a few other ways we can slice it. And it goes through and tries to identify the root cause. If it's able to identify some kind of cause that's actionable, it'll create a GitHub issue for us. And then we are now rolling out ways that the experience here can go and actually fix the bug for you and tag the correct owner, which is super cool, right? Because I just found this one randomly from 5 days ago. This was an error that our bot found, ran through, and shared the stack trace. There's really no other data that we had from our telemetry here. And I just peeked, and I saw that it had gone through and actually fixed it for us, right? So this was a regression from May that we detected. It explained to us kind of the code flow.
𝗦𝗲𝗀𝗀𝗀𝗀🐬 was
Oh no, sorry, buddy.
He's the audience.
Yeah, and it kind of ran through. And I think the interesting part of this bug is that you can see from this nice diagram here is that the actual bug spanned a few different processes throughout VS Code. The extension host, and it went through to the main thread. There's like this kind of back and forth of like serialization of data that caused the bug to happen, and it was able to step back and understand the sequence of events that were causing the exception to be thrown, and then actually fix it for us, right? So it identified the files across various parts of the code base, across various processes, and was able to suggest the fix for us. And it was accepted by Rob, so I'm sure it was great.
Rob approved it. It's all
yes.
good. Rob knows all.
Yeah.
But this is cool. This is like full loop, right? Like,
Yeah,
so
absolutely.
we have an issue, right? It shows up in our error site, right, from our workflow that we were just talking about. There's an initial investigation done. We get an issue open with that investigation.
Right.
And then if Copilot thinks it can go tackle it, like it did in this case, then it proactively proposes a fix. And then, you saw that. Like we have, many tens of millions of users using VS Code every single month. Like
Exactly.
there is a lot of like small little things that can crop up, and before, unless it was something major, it's hard to prioritize the time for that. And now this is just happening automatically in the background.
Absolutely. And I mean, we're still a really small team, right?
Yep.
Like, we don't have 100 engineers working on this project.
Exactly. We're like 40-ish people. I think
yeah.
people assume we're like a 1,000-person org or something.
Absolutely,
like this,
yeah.
But we're not, right?
So it's like we don't have the time in the day if we work 24 hours to go and fix all these bugs. We really need AI here to make the product stable. The last thing I want to just kind of talk over a bit is, like the weekly releases have been huge for us. This has been a big shift in how we develop, how we communicate. That was nice. We just saw an update here. So this is live kind of data from our, from I guess like the update server that every day when you open like Insiders, or every week when you open Stable, you'll get an update, and this is the same data that is actually driving the update server as well. So you can see kind of all of the versions of VS Code that we have actually released. You can see the rollout. We now do staged rollouts kind of slowly, so we can observe the effects of that in the wild, because of course in Insiders and from us using the product is of course very different from the whole world using it, from like the 40+ million users. You can see the version that we're actively rolling out, and then the version we're actively developing. In this page is growing every day, and like the kinds of data that we're presenting. We've got a whole bunch of tools to understand the code that we're rolling out, and to make it really easy to, you can see this was frozen for a tiny bit of time because of a problem after we got to 8%, right? So we were able to catch something really quickly before it became a problem for most people, right? So.
And we incremental rollout is kind of a newish thing for us. We used to just like YOLO to 100%, right?
Totally.
So.
Yeah, and we have built in the process of incremental rollouts and being able to freeze builds to fall back to previous builds, all on our build site, which we've used for a while, but this has grown a lot as the needs that we've seen have expanded. Able to start rollouts, freeze, do the specific rollout for a specific version of VS Code incrementally. A lot of those kind of nuances we never had to really think about, and now we do. And we have built a lot of tooling around it. Cool, yeah, so That, I think, is a lot of our process changes. Of course, as I said, there's a lot more that I didn't cover, and there's a lot more scary diagrams here that I didn't cover as well. But yeah, for our next talks, maybe.
Yeah, I mean, I think like, it's easy for teams not to prioritize this sort of work, but like on our team, this is literally people's jobs, right? Yeah. Is to go and build these systems, because if we didn't have these things, even pre-AI, that would be scary, right? And now with all of us moving faster, there's obviously much more risk in the system. So you really need to like make a very conscious effort, no matter how hard, to invest in your engineering systems. And that's something I've always appreciated about the VS Code team. OK. For our last little bit here, since we only got 5 minutes left, I wanted to quickly talk about like some of the changes on our collaboration model on the team. And so I think there's this interesting thing that's like, when I first joined Microsoft, I would write like a quarterly plan or a 6-month plan, and I would review this, or yearly plan, right? And then that became, OK, you need to produce monthly plan. And then it was like, OK, you need to produce weekly plan, and in some cases daily plan, because the delivery life cycles are so collapsed. And of course, with AI, there's the temptation. You can literally do anything, right? We can add any feature to VS Code. But the discernment to add the right set of features to VS Code is very challenging. And especially even at our size, 40 people, like if 40 people managing that size team is challenging. And then now if everyone's supercharged with AI, that becomes its own risk, right? And so the way we used to work, I don't know if all of you have gone to the VS Code repo. We pin like our monthly plan. It's assigned owners from our team. We have like issues, and they link out to different things with more details. And so the way that used to work pre-AI is like the leads would basically say, OK, we think we need to add X, Y, Z thing. The space is going this way. So you kind of have like that setting from top down. And then obviously the people closest to the work, right, working on individual features, have sets of things that are like, I think it's really important we add this. And so during our in-game week, which is like the week when we're doing testing, planning for the next week, that's when we're actually going and reconciling all these things before we produce a plan that you all see the next Monday. So that was kind of our process. And you had like areas, I work on the workbench, so like workbench things are coming in, or I work on chat, and so chat things are here, or agents, or MCP, and you would have these like very predictable sections that would live on the plan month to month to month. But I think, like I was saying, like that whole model broke for us because AI is moving so fast, right? If someone asked me, I think we have directional like vision, but like I can't tell you exactly in 3 months from now what is the exact feature we're going to land in VS Code. That's not how it works anymore, right? Our delivery life cycles are so collapsed that that's just not how it works. So that's a problem. Alignment, I already mentioned that. Like, how do you keep 40 people aligned when they're all moving faster? And then the compressed life cycle for delivery. And so like the really tricky thing is like, how do you make sure that your judgment is still exercised in this whole process so that you're not just adding random things to your product because you can, you're actually applying this. And so basically what we knew we had to do on the team is we had to basically totally rechange like how our whole collaboration and planning model works. And so basically, rather than having these kind of durable, like I work on this thing, and I've always worked on this thing as my code ownership area, we have work streams. So we still kind of have like the top down, bottoms up, but like we have things that's like, hey, like for build, we are launching this new MAI coding model. We need to go make sure that it's an awesome experience in the product. The prompts are tuned. The infrastructure is good. OK, let's go literally stand up a group of folks who focus on that problem for like a week or two. Mm-hmm. Or like the website or the docs, even things like that. Those need an update. OK, what is the goal for that? Let's stand up something for that. And so you have these like temporary work streams that are built up and torn down based on priority. Each one has a DRI. That person's responsible for planning the work for that area. Each of those groups meets, in some cases daily, sometimes multiple times a week, depending on the pace of the work stream. And so like that's how we're staying in alignment. You're breaking down into groups of 2 or 3. You're meeting in the morning saying, what do we need to do today? You work all day. You meet again in the afternoon, maybe asynchronously, and you say, this is what we got to. And so this is, we don't know if this is going to work for us. We're 2 months into this exploration. I do think it's made us much more agile. It's created other issues, right? Because if we're creating these like work streams that we're building up and tearing down all the time, then that obviously creates its own challenges, which we're dealing with as well. So yeah, like we really kind of had to totally rethink how we actually plan VS Code and deliver features to you because of AI. So yeah, I guess like the last thing I want to leave you with is like, many of these talks are going to say you should use better AI. You should, right? Like all of us are extremely AI pilled on the VS Code team. But you also have to consider, OK, what happens if I'm successful with AI? You're going to have to evolve the way that your team works as well. And we were excited that we were able to share a couple strategies that work for us on the VS Code team. But we'll be hanging up here after the talk, so we'd love to hear about your stories and any suggestions you have for us. And we can definitely share lessons learned for sure. So thanks for coming to our talk.
Thank you. Wow, that was right on the money.
Right on the money.